First, select Connect to Chassis to reserve the ports. Currently, the L1 service is available on modules and appliances that support auto negotiation and link training. Specifically, Spirent Test Center 400 gig, DX3, PX3, QSFP, DD, form factor test modules and appliances, and supported speeds in the first release are 400 and 200 gig. In the future, all new hardware with speeds of 100 gig or higher will support the L1 service. However, there are no plans to support other existing or older modules. Finally, automation is supported and L1 service results are viewed using Spirent Test Center IQ. After reserving the ports which support the L1 service, from the test configuration, select each port and set the performance mode to STC-L1 mode. This will change the FPGA image to support the L1 service. In this mode, there are still emulation capabilities, for example, BGP and DHCP, but will only have limited PGA capabilities, meaning you can have port-based but not stream-based stats. Next, select the speed which you wish to operate. The main difference between 50 gig, 100 gig, 200 gig, and 400 gig from an L1 service perspective is the number of lanes available. With PAM4, pulse amplitude modulation with 4 levels, the minimum speed for each lane is 50 gig, so 400 gig has 8 lanes and 50 gig would only have 1. Finally, select the port's L1 config group under Capture under the port. L1 services are configured by selecting the L1 config group under each port. Then you can access the appropriate tabs. On the right, test results are displayed in the Spirent Test Center IQ web-based application, and we'll come back to this later. Now we'll walk through the L1 service port control panel tab settings. The link fault signaling section lets the user determine how faults will be generated from this port. Link faults can be signaled as a local fault code word, remote fault code word, and can be generated either continuously or for a limited time period. When you generate a local fault condition, the DUT presents a remote fault condition. When you generate a remote fault condition, the DUT presents idles. You can start or stop the link fault signaling by selecting the Start or Stop Fault Insertion buttons. Next, the TX PPM or parts per million adjustment allows the user to adjust the port transmit clock by a variable amount from the center frequency. The standard allows drift between -100 and 100 ppm, and Spirent Test Center can be configured accordingly. The user can also configure for link recovery and to enable or disable auto negotiation or link training. Relative to auto negotiation, with link recovery enabled, the port will keep trying until the link comes up. With link training enabled, the port will work to find the optimal setting depending on the type of transceivers, cable lengths, and conditions. Otherwise, these can be set on the PAM4 ANLT transceiver tab. Ignore link status allows the user to configure to ignore received faults when determining the port's local fault status. Select to allow the port to continue transmitting traffic if the connected ports on the DUT go down. Finally, the module information section is read-only display of the port's QSFP transceiver module information. This is only high-level information, whereas the more detailed information is accessed from the module's register tab. The module's Registers tabs provides access to the internal registers of the QSFP transceiver module. The user can read or write to any of the value allowable registers under the QSFP specification. This is indicated in the application by the read-write column. The registers are displayed showing the lower page on the left and the upper page on the right. The drop-down boxes in the upper right allow the user to select a different bank or upper range to be displayed on the right side. The module reset button in the upper left reboots the transceiver to return the module registers to their reset values. Finally, the refresh registers button will issue a new read to each module registers. Note that you must press the apply button in the application shortcut bar for the changes to take effect. The PAM4 ANLT transceiver tab allows manual configuration of the PAM4 transceiver for the port. Note that in order to adjust any TX parameters, ANLT must be disabled under the port control panel, as previously discussed. The configuration table allows for the configuration of each PRBS lane, including transmitter enabled and transmitter equalization controls, including pre-emphasis tap, main tap, post-emphasis tap, and TX course swing. The link is expected to drop when emphasis values are changed. If the emphasis values are valid, link recovery, set on the port control tab, should bring the link back up shortly. If link recovery is disabled, the link will stay down. As mentioned, disabling a transmitter is accomplished only when both auto negotiation and link recovery are disabled in the port control panel tab. Because auto negotiation and link recovery will automatically turn any disabled transmitters to negotiate transmit parameters or bring up the link, you must manually disable both. When you disable a transmitter, you are effectively muting the transmitter lane. Also, receiver equalization controls for DAC or loopback cables are selected by the Port Group RX Mode pull-down menu. Select the mode for all lanes as loopback, optical, or DAC. Note that these settings affect only transceiver characteristics. They don't enable loopback or other port configurations. And finally, there is an iScan enabled checkbox and a LED to indicate when iScan is enabled. And notice the Start/Stop iScan button in the upper left. The iScan reports the voltage characteristics of the PAM4 signal. It's a measurement of the received voltage levels. Enabling iScan will determine if the iScan histogram is available in the Test Center IQ results. I will show more on iScan later in the results. Finally, please use the context-sensitive help, in other words, press your F1 key in the application to see discussions regarding the taps and TX course swings. Note that for the result demo, I am enabling iScan and starting. Of course, now you can see the iScan state turn green. The PRBS Lanes tab allows the generation of a PRBS diagnostic pattern for the port. Each lane can be configured with a specific PRBS pattern by selecting it from the TX pattern pull-down. Spirent Test Center supports PRBS 7, 9, 15, 23, and 31. When a lane is generating a PRBS pattern, the PRBS state LED will light to indicate the status. Once a lane is enabled, the user can inject a single PRBS error by selecting the lane using the checkbox and then pressing the PRBS Inject One Error button. Note that what we are talking about here is Layer 1 unframed PRBS, where we just send PRBS continuously. Not to be confused with enabling PRBS in a stream block, which is considered framed PRBS, where we only replace a portion of the frame content with a PRBS pattern within the frame boundary. Framed PRBS is at layer 2 or above, and both framed and unframed PRBS can be sent together. When Spirent Test Center transmits PRBS, the link goes down, and the port attempts to recover the link and to negotiate link parameters. For this reason, when you configure a port to send a PRBS pattern, Spirent Test Center automatically disables link recovery and auto negotiation on the transmitting port. Likewise, to detect PRBS on a receiving port that is not configured to transmit PRBS, you must manually disable link recovery on that port. The PRBS detection engine is active only when link recovery is disabled. If the receiving port doesn't detect PRBS on a given lane, Spirent Test Center reports none for the pattern detection and increments the total seconds of no PRBS pattern received result. It may take up to 10 seconds to detect PRBS on all lanes. The PCS Lanes tab allows the user to adjust the transmit lane skew. TX skew bits are the number of bits of delay to add to the signal. Each lane can be configured with a skew relative to the other lanes between 0 and 79 bit times. Once configured and applied, the default skew will be displayed in picoseconds in the delay column. These PCS lanes are actually virtual lanes within the PHY, and each is running at 25 gig. So at 400 gig, there are 16 virtual PCS lanes and 8 physical PRBS lanes. The idea is that the port is a bigger pipe, say either 50 gig, 100 gig, 200 gig, but for transmit is divided into smaller paths or lanes. Then the receive side must rebuild the whole pipe by first realigning the individual lanes back to their original state. More or less skew per lane will have an impact on resyncing the lanes. So basically, you are testing the alignment logic for the port, meaning how well the port can find and lock on the alignment marker. The following are the same for the FEC error injection and random error injection tabs, so I will not be reiterating this in my description of those. At the top, select Clear PCS Results to clear PCS FEC error and random error statistics. Select Clear PCS History to clear the PCS and FEC-led indicators, and any latched error condition captured will be cleared. The FCS Error Injection tab allows the configuration of the targeted FEC error injection for the transmit port. The user can corrupt either the beginning or end of any code word. Start a code word is used to select one or more bits to create start a code word mask. The right column displays the hex value of the code word mask. End of parity is used to select one or more bits to create the end of parity mask. The code word selection section allows the user to select the first, second, or third code word of the code word A, code word B pair. This allows the user to test the FEC alignment logic, because the standard states that if the receiver detects 3 consecutive FEC corrupted code words, then it should break the link. Also note that for 200G and 400G, there is actually a twin FEC engine running. Therefore, you can select either code word A or code word B, whereas only code word A would be applicable to 50 and 100G. The bit selection section allows the user to configure the individual bits in the code word symbols. The mask bits are selected by checking the associated boxes, while the resulting code word mask is updated above. Once the desired code word is configured, select the Inject Single Error button below to inject one error. The Random Error Injection tab allows random bit errors to be enabled for the transmit port. The port error injection rate is specified using the dialog box and the drop-down section at the top of the screen. Note that 1.0E-3 means a single error will be injected every 1 millisecond. The configuration table will enable the lines to apply the injection. If multiple lanes are enabled, then the rate is divided between them. Once the Apply button on the application shortcut bar is pressed, the error injection state LEDs will indicate which lanes are injecting the errors. Next, we'll take a look at the Test Center IQ L1 service results. But first, we'll apply. And now we'll launch Test Center IQ, either from the classic result toolbar or from the View menu. Test Center IQ results are web-based and will launch in Chrome or Firefox once selected. These are the two supported browsers. See the STC Application Tools Options Test Center IQ to specify your default browser. The first thing that comes up in Test Center IQ is the results library, which shows all results for both the current run, which we just started, and all previously completed tests. The status icon displays the difference, whereas the top item is the currently running test. And the items below are previously completed tests. You can view a test results using the results dashboard accessed by selecting the current or previous test name link. I'll select this for the currently running test. L1 statistics are displayed in 9 default views. Note that the Layer 1 results profile is applied automatically for a Layer 1 enabled test. The different views associated with the L1 results profile are as follows. L1 port results displays per port information about the port link status, received clock drift, and temperature states. L1 port PCS results shows more details about the port, and as is the case with most views, you can use the hamburger menu to choose which stats to view. The PCS or FEC-related stats can be cleared out from the STC application from the PCS lanes or FEC error or random error injection tabs by selecting Clear PCS Results. In addition, the Clear PCS Histories buttons will clear the LED status. The LEDs provide a single event status, whereas green indicates good and active, yellow indicates there is intermittent behavior. And after selecting the Clear PCS history, it will display the most current value. L1 port FEC symbol error results displays a histogram of buckets for symbol errors detected in each code word. The symbol error bin has a row for each number of bit errors detected in each bucket. 0 equals no symbol errors, where 1 equals 1 symbol error, and so on. L1 lane PCS results reports per lane stats, including virtual port mapping, receive skew, and per lane symbol error performance. L1 lane transceiver results reports per lane transceiver stats, including signal detected status and loss of signal event counts. L1 lane PRBS PAM4 results reports the PRBS pattern detected on a per lane basis and other per lane PRBS related stats. The L1 time chart allows stats and events to be displayed and recorded over a period of time. By default, the duration is 15 minutes and can be modified in the STC application's Test Center IQ settings. Also, during this period, the vertical line will delineate when events occur. L1 PCS skew chart displays lane skew relative to the lane skew of other lanes from the selected port. The upper right menu will allow you to select which lanes will be displayed. Finally, the L1 transceiver iScan chart shows a chart of the PAM4 transceiver lane. The bottom axis specifies the voltage sampled, while the vertical axis shows the number of samples detected at the indicated voltage. Now let's add another lane. Notice that the data for the iScan chart for each lane is gathered persistently so that trends from the samples can be determined. Thank you for taking the time to watch this user training for the Spirent Test Center Layer 1 services.